Welcome to a new video about Introduction to Limit. I'm thinking a nice series which will cover almost all the topics about limits. I guess it's gonna be something around 20 videos. In this first video, I will show you what is a limit and I will solve illustrative examples about subjects. If this is your first time here and if you want to support this channel, don't forget to subscribe, click on the bell to turn on the notifications to be aware of the upcoming videos. We have a lot to cover, so let's get started. We can think limit as approaching value. For example, let's say on such a coordinate system we have f of x like this, and at the point a over our function a corresponds to a value of b, and once you approach that a from the right side means just a little bit bigger value than a, and over our f of x the value approaches to b. And again, if you do the same thing from the left side, if you approach a from the left and the value approaches b from the left also. So this is represented in this form. Limit of f of x when x goes to a from the right side, that plus means the right side, okay? Plus means right side. So when you approach f of x, and if limit is b, and if you approach f of x when x goes to a negative, a minus, that means if you approach a from the left, and still if it's gonna be equal to b, and if those values are equal to each other, as you can see they are equal to each other, and then we say that the limit exists at the point x is equal to a for f of x, and that is equal to b. So in order to say that a function has a limit at a point, both limits from left side and from right side, they have to be equal to each other. And let's take a look at some examples. For example, here we have a function f of x and its graphic, and in a it says what is the limit of f of x when x goes to 1 from the right side. So over the function f of x, as you can see from the right, the function comes like that, okay? When you approach 1 from the right, the value is approaching to 2. Don't look at here, okay? Because at the point 1, the function is defined here. Because this is filled, that means this function is defined at the point 1 as 4. So this is not limit, guys. We have to look at the function where the function is approaching, the value of the function is approaching. The value of the function is approaching to 2. So this is 2, guys. When x goes to 1 from the left side, over the function I'm approaching 1 from the left, and the value is approaching to 2 also. And because right limits, sometimes this is called right limit, and the left limit, they are equal to each other. Because of that, when x goes to 1, the limit is 2. Why? Because left limit and the right limit at the point x is equal to 1, that is 2. So that is why when x goes to 1, the limit is 2, guys. We can say that f of 1 is defined as 4. That's all this filled point tells us, okay? F of 1 is 4, but that doesn't mean that limit of f of x when x goes to 1, that is 4. This is about continuity actually, and we will take a look at this one more time when it comes to learn the limit and continuity topic, but just keep it somewhere right now. Let's continue with our next question. D. It says what is the limit of f of x when x goes to 3? So when x goes to 3, that means we have to look at the limit from the right and from the left. So limit of f of x when x goes to 3 from right, guys. Approach function from the right side, and as you can see the value approaching to 4. So this is 4, guys. And now I have to look for the limit at the point x is equal to 3 from the left also, f of x, and when x goes to 3 from the left, and still I am going to 4. And because those values are equal to each other, and then I can say that this is equal to 4 as well. So the limit of f of x when x goes to 3 is equal to 4. And let's take a look at the next example. We see the graph of the function f of x, and in a we are asked to find when x goes to 3 from the right. As you can see, the function is approaching 3. So the limit is 3. That means the limit of f of x when x goes to 3 from the left over the function, that is extremely important. Okay, on the function we approach x is equal to 3, and the value on the y is approaching 3 also. So that is 3 as well. And what is the limit of f of x when x goes to 3? because left limit and the right limit at the point x is equal to 3, they are equal to each other, and then that limit is 3 as well. And in D it says, what is the limit when x goes to -1 from the right? Over the function I am approaching -1, and as you can see the y value shows -2 here. So this is -2, guys. And in E it says -1 when x goes to -1 from the left. So from over the function, that is extremely important. Over the function I'm approaching -1, okay, because this is -1. And my value right now becomes 3, guys. At this point we have 3. Okay, if there would be a question like what is, okay, let me write it here. What is the limit of f of x when x goes to -1? And I would say that because left limit and right limit at the point x is equal to -1, they are not equal to each other, so there is no limit. No limit at when x goes to -1 for f of x. Why? Because their values, left limit and the right limit, they are not equal to each other. That is why there is no limit when x goes to -1 for f of x. Anyway, and let's take a look at G. It says when x goes to 4 from the left side. Okay, this is 4 from the left side. The value is 5, so this is 5. What is the limit when x goes to 4? In order to answer this, I have to look for the limit when x goes to 4 from the right side as well, okay? So just let me write it here. Limit of f of x when x goes to 4 from the right, and that is from the right side. If you approach 4 from the right side over the function, as you can see, I'm approaching 4 here. 4 from the right, and my value is approaching -2. So that is -2, guys. Because the right limit is -2 and the left limit is +5 when x goes to 4, and because they are not equal to each other, so when x goes to 4, there is no limit, guys. No limit. And let's take a look at the next example. In this question, it says, what is limit of f of x when x goes to 2, where the function is 4x minus 3. So let me write it here. Limit of f of x when x goes to 2 is question mark. In such questions, guys, especially when our function is a polynomial function like here, all we need to do is just put 2 instead of x. That's all we need to do, guys. Okay, we don't have to look at the limit from the right, from the left, because once you do, then we're going to get the same thing. Okay, you don't have to do that. You don't have to spend more time on it. So just all we need to do is just plug 2 in x, and that's it. So that is equal to, at the same time, limit when x goes to 2, 4x minus 3 is equal to what? That means this, guys. Just put 2 instead of x, and once you do it, we're going to have 4 times 2 minus 3, and that is 8 minus 3, and that is 5, guys. So the limit is 5 in this case. As I said, when you have a polynomial function, just put that limit, whatever that is. In this case, it is 2 instead of x in the function, and you can just evaluate the function at that point. And let's take a look at our last question. In this question, we have a piecewise function, and in A it says, what is limit when x goes to 1 for f of x? In such questions, guys, we need to look at this value. It is 1, right? And 1 is in which interval? So we need to find the range for 1. And because 1 is less than 3, so this is the function that we will work with. Okay, so because that 1 is not in the boundary here, okay, because the boundary here is 3, the critical value, this is called critical value, by the way, the critical value is 3 and it's not 1, so we don't have to look at the left limit and the right limit. Okay, we just put x is equal to 1, whichever the function is defined for that interval. For example, here our function is 2x plus 5, so we will just put 1 instead of x and we will just evaluate it. That's it. Because it's not a critical value, but here we have a critical value. we will use a different strategy here in B, but for A, all we need to do is just put 1 instead of x. That's it, guys. So once you do it, we're gonna have 2 times 1 plus 5, and there is 2 plus 5, and there is 7, guys. It's that easy. But when you look at B, and it says what is the limit of f of x when x goes to 3, and because 3 is a critical value here, okay, so we have to look at both cases from the left and from the right, and we should get the same limit in order to say that yes, the limit exists at that point. So let's take a look at the limit from the left side. Limit of f of x when x goes to 3 from the left. Okay, from the left means a number that is very close to 3, but that number should be a little bit smaller than 3, for example 2.99. okay, so this 2.99 is in which range? Of course the first one, because 2.99 is less than or equal to 3, so that is the function that we will evaluate, and that is equal to, guys, don't put 2.99 instead of x here, just put 3, that's it. So don't make such mistakes. And once you do it, we're gonna have 2 times 3 plus 5, and that is equal to, guys, 6 plus 5, which is 11. So we found out that the limit of f of x when x goes to 3 from the left is 11. And now we need to look at the limit from the right side as well. So limit of f of x when x goes to 3 from the right, and that is equal to, guys, so from the right means a number just a little bigger than 3, let's say 3.01. okay, so 3.01 is in which range? Of course the second one, because the number is greater than 3. So this is the function that we're going to evaluate. That means we will evaluate this function, and once you do it, so just plug 3 in x in our function, and it's going to be 3 squared plus 3 times 3 minus 7, guys. So it's going to be 9 plus 9 minus 7, and that is 18 minus 7, and that is 11, guys. And as you can see, we got 11 here, and we had also 11 here. So because left limit and the right limit are equal to each other at the point x is equal to 3, and then we say that yes, when x goes to 3, the limit of f of x exists, and that is 11, guys. That is how we can solve the limits in piecewise functions as well. And this video was just an introduction, guys. As I said, there are a lot of different topics and different kind of questions in this topic. I'm planning to make it something around 20 videos to cover almost all the topics related to the limit, that subject. Thank you for watching, and see you in the upcoming videos.